Okay, let's look at how to multiply a whole number and a mixed number. And I want to show you how to do the model for that, as well as the algorithm. So if I started with 3 times 2 and 4/5, I've got a whole number and a mixed number. That means I want 3 of 2 and 4/5. So the model would look like this. I want 1, 2, and 4/5. So I need to make fifths out of this. 4/5 would be up to there. I also want to make 4/5 fifths out of these, and fifths out of these. And the whole thing, 1 whole, 2 whole, and 4/5. That's one group of 2 and 4/5. I want 3 of 2 and 4/5. So I'm going to do this another time. One whole, 2 wholes, and 4/5. That's the second group of 2 and 4/5. And now I have my third group of 2 and 4/5. So I have 3 of 2 and 4/5. 1, 2, 3. 2 and 4/5. Now I want to see how many fifths do I have. I've got 1, 2, 3, 4, 5/5, 10/5, 15/5, 20/5, 25/5, 30/5, 31, 2, 3, 34, 35, 36, 37, 38, 39, 40, 41, 42. So I have 42 fifths. So I'm going to write 42 fifths. And I know that I can't leave that as an improper fraction, so I'm going to divide 5 into 42 to get a mixed number. 5 doesn't go into 4. 5 goes into 42 8 times. It's 40. With a remainder of 2 over 5, 8 and 2/5. So there's the model to go with it. Now, if I want to just show 3 of 2 and 4/5 with the algorithm, I'm going to change 3 to 3 ones. And I'm going to change 2 and 4/5. I'm going to do my little football helmet. Multiply the denominator and then add the numerator. 5 times 2 is 10, plus 4 is 14 over 5. I can't cross simplify, so I'm going to go ahead and multiply 3 times 14. I'm going to use my workspace over here. And I get 42 over 1 times 5 is 5. 42 fifths, just like before. And I can't leave it as that. I go to change it to a mixed number. And just like before, 8 and 2/5. So that's how I multiply a whole number and a mixed number with the model and with the algorithm. Now let's say I want to look at just multiplying a fraction and a mixed number. So to do that, I'm going to use 1/2 of 3 and 2/3. 1/2 of 3 and 2/3. So I'm only going to have one group of 3 and 2/3, and I want to show half of that. So 3 and 2/3, I've got 1, 2, 3, and I got to get 2/3 in here, so I'm going to partition this into thirds, and I'm going to show 2/3 like that. I'm going to partition all these in thirds, and I'm going to shade them all in, so I have 3 wholes and 2/3. I'm going to also bracket this 3 and 2/3. Now I want half of that. So if I want half of that, I'm going to partition it all in half. And I'm going to shade in where, here's 1/2, where the 1/2 and the 3 and 2/3 overlap. And that's going to stop right here at 3 and 2/3. Now I've made a new unit. I went from thirds to now my unit is sixths. And I want to know how many sixths is 1/2 of 3 and 2/3. And that's 1/6, 2/6, 3/6, 4, 5, 6, 7, 8, 9, 10, 11 sixths. 11 sixths. It's improper, so I'm going to change it to 1 and 5/6. Now I can check it by using just the algorithm. 1/2 of 3 and 2/3. 1/2 I can keep as 1/2. And 3 and 2/3 I'm going to change into an improper fraction. 3 times 3 is 9, plus 2 is 11, 11/3. I can't cross simplify, so I'm going to multiply across. 11 over 3 times 2 is 6. And that equals 1 and 5/6. So I can show that using a model and using the standard algorithm.